Good morning and good evening and good afternoon for the people joining from different time zones. I really appreciate all of you for your time, spending some time and joining us for today's webinar. I'm Rizwan Rafique and I am currently a postdoctoral researcher at University of Florida, based in Quincy. And today I'm going to present some of the results of my PhD studies. I graduated from PMSR Agriculture University, Rawalpindi, Pakistan, in an exchange program with ABE department at University of Florida. And I was born and grew in a vineyard and orchards, and the thing it really fascinated me. And I always wondered about the phenology, how the bud burst, and how the temperate crops they behave. So I selected the topic as utilizing heat unit approach for predicting grapevine phenology, physiological responses, and food quality at harvest. As I walk through my presentation, I'll discuss some of the basic things on grapevine phenology and physiology, food quality, and how the modeling approaches can help in predicting these responses, or to what extent we can predict these responses. And the summary, and then the conclusion. And before I go on my further discussion, I want to introduce about the grapevines and specialty crops. Specialty crops, they are often ignored, but still they had a contribution of around 1.6 trillion US dollars in global economy, and that's going to increase. And among all the specialty crops, grapevines are the largest fruit crop, and the global vineyards, they cover area about more than 7 million hectares. And that is predominantly dominated by wine grapes and the table grapes and dry grapes. We see here the 5 big producers on the left panel on the map: USA, Spain, Italy, France, and China. They are the 5 top producers of the grapevines. And the red color, it indicates the wine grapes, which is predominantly in the traditional viticulture regions of Europe, US, South America, and even Australian continent. And there is a rising trend of table grapes. Over the last couple of years, there is a declining trend in wine consumption due to less alcoholic wines, and climatic variability is also playing its part in reducing the area under vineyards in traditional regions. On the other hand, the table grapes, they are increasing, and during last 5-6 years, 15% increase has been recorded. So on one hand, there is a decreasing trend, and on the other hand, there is an increasing trend in the table grapes. It is important to know here that table grape cultivars, they have some differences compared to the wine grapes. They are harvested earlier with lesser bricks, usually 16 to 18 bricks, compared to the wine grapes, which are harvested at 22 bricks. The berries are smaller, they have seeds, the skin is thick. So one of the other issue with the table grapes, we are also concerned with the firmness and berry quality, because they have to be transported, and the supply chain, they need a good quality with a proper harvest precision in terms of fruit quality. So the study was carried out in a non-traditional viticulture region. Compared to the traditional viticulture regions, there have been long-term phenological data sets. Fruit quality data sets are also available, where in this region, non-traditional viticulture region, there has been grapes growing in the traditional viticulture region that is marked with a red circle, where with a high return that was 6 times higher compared to the other crops growing in the Punjab. The blue circles on the right, it is Potoha region, and it is the South Punjab. The grape cultivation, it spread to these regions. The early maturing cultivars that ripen in September to November, they were cultivated in the traditional regions, but the new regions, emerging regions, they had early maturing grape and cultivars that were cultivated that were harvested in June, July. So these fertile plains of Punjab, they offer a huge potential for the viticulture. So over the last a decade and a half, many new cultivars they have spread in this region, and more than 60 cultivars they are reported in this region. But unfortunately, many of them they don't have phenological data sets and physiological data sets. So the key phenological stages of table grapes, they are really important because we cannot change the region, variety, soil, as they are the permanent feature of vineyard. But definitely there is variability in terms of temperature, rainfall, humidity, and solar radiation. They vary interannually and affect the grapevine phenological cycle. On the left side of panel, there are the vegetative and reproductive stages of grapevine, starting from the bud burst to maturity. All these photographs I captured myself, and it was really fascinating to observe how the vines they behave from being dormant to the full maturity. And among these factors, temperature is considered as a key driver of the phenological development, and also the temperature variability affects the physiological activities of the vine. So if we look at the effect of seasonal variability on the grapevine phenology, these are the 5 main phenological stages on the right side of the panel: bud burst, bloom, berry set, virisin, and harvest. I'm gonna focus on these in terms of phenology and physiological responses. And elevated temperature shortens the duration between the stages, days between the stages, and total period from the berry set to harvest. It also affects the photosynthetic activity. Temperature goes on increasing, and optimum window is around 25 to 30 degrees Celsius. Elevated temperature above this level, it negatively affects the photosynthetic activities. What occurs in terms of quality, the elevated temperature may increase pH, soluble solids, maturity index, and sugars, but it decreases the titratable acidity, ascorbic acid, polyphenols, and anthocyanins, as they are really important and help maintain the balance in terms of fruit quality and sugar acid ratio. It's really important to understand these. Then when it comes to the thermal acclimation of the vines to the physiological responses, we can see here 2 vines taken on the same time of year, same day, on 2 different vineyards. One of the vine is healthy, sugar one vines, and on the right of the panel, the vine, they are affected by the heat. So I'll discuss that 35 is a temperature where after this temperature, the vines, they decrease their photosynthetic activity. And after a certain temperature, usually 40, the photosynthetic activity is severely affected. What we can do some adaptations, and we can switch this window to 2 degrees Celsius, that vines can still keep on normal photosynthesizing. That could be in terms of additional supplemental irrigation, in terms of application of some anti-transparents, and in terms of application of some other hormones that can mitigate the effects of heat. Otherwise, the vine will look like this, and in a matter of couple of days, the whole vine will defoliate. There will be no bunches. In terms of physiology, it's really important from the research perspective, but for the grower, the harvest decision and berry ripening, it's really important. On the right side of the panel, there are 2 berries in their different development stages from their color. Top one is the colored variety, and bottom one is the non-colored or yellowish green perlet, and top one is the King's Ruby. So in majority of the vineyard, the harvest decision is based on color, not the internal fruit quality, because it's really hard to monitor the fruit quality, internal fruit quality in terms of sugar as well. We can sample few berries, but we cannot sample a lot of them. So we have to exclusively rely on the color development and firmness that we feel. And even many of the AI approaches, they utilize the color development as a criteria for their harvest decision. That could be and could not be a good harvest criteria because in our data, we have data to support it that there is a likelihood that under colder conditions, there might be early color development with lesser sugar, and there might be high sugar contents with less color development. Sugar acid ratio and anthocyanin acid ratio can vary. So it's really important to have a good decision based on some tools that can help us in predicting the maturity time. Traditionally, the crop growth modeling approaches, they have been evolving last couple of decades, and many cropping system models, they have took the place for many different crops. Like DSET, it counts for more than 40 crops. I'm currently working on DSET simulations and EPSIM and sticks. But one of the limitations with these models is that they need a lot of data in terms of soil initial, nitrate, crop residue, whole management. Unfortunately, in most of the horticulture production systems, especially tree fruits, such information is lacking. And it is really important. And right now, among these main cropping system models, sticks is the only model that has a robust, complete module to simulate the vineyard production system. EPSIM, it has designed a basic module, but that limits only to the bud numbers and yield predictions. So what we can do in terms of predicting, that is a temperature-based model that can help us make decisions in terms of how we can use these modeling approaches with limited data set. And I'll discuss those in next slides. The goal of our study was to assess the effect of seasonal variability on grapevine phenology, whole grapevine cycle, starting from dormancy to the harvest, and then how wine behave during the seasons. Fortunately, we have 4 seasons where this study was conducted. There are limitations in the tropical regions. I'm not going to discuss that today. And then we had to identify the critical growth stages in the grapevine life cycle, where the management operations can help have a good yield and help in the sustainable vineyard management. Another specific objective was to develop models based on growing degree days information for phenology predictions and quality predictions in table grape cultivars. So for this study, the sites were selected based on survey in the Pothohar region that's located in northern Punjab, Pakistan. And the sites, they were about 100 miles away from each other. And the survey was conducted in terms of having variability of the climatic factors and the vineyards that had similar vineyard practices. So both vineyards, they had different elevations. And we see here that Chakval has higher minimum temperature up to 1.6 degrees Celsius. And similarly, it has higher maximum temperature that hits 40 degrees Celsius, compared to many of the traditional viticulture regions in Europe, where the temperature doesn't exceed 35. In this region, it's really common to hit 40, above 40, up till 45 in hot summers. So the selection of wine, I'm not going to go much detail in this slide, but we used vertical positioning system, same management practices for both locations. And the phenological measurements, they were recorded on the quantitative Econs and Laurent phenological stage. That gives us numbers for the descriptive stages. And these numbers help us in our modeling efforts. And then we calculated heat units based on base temperature of 10 degrees Celsius and upper threshold of 37. And if you're interested in detail of it, you can read more in our article published in 2023 and another in 2024 and 2025. I'll share the links in the chat later. If you are interested, you can find more details. So then is the growing seasons. 2 growing seasons. In all the cases, Chakwal has higher T mean and T max up to 1.6 and 1.3 degrees Celsius. We see here the left side of the figure shows Chakwal. That is a relatively hotter location. Right side is the Islamabad. So we see here that maximum temperature is 40 degrees Celsius, close to June, but Islamabad has slightly lesser temperature than the Chakwal. And the red lines, they indicate the hotter vintage of 29, and that's in all the cases. So if we look for the phenological progression, it follows the same pattern as the temperature availability. One of the interesting and fascinating thing I want to discuss here is that there is a lot of variability in terms of spring phenology. Like bud burst, it has a lot of variability up to 2 weeks. In all the cases, the red lines, they indicate the hotter location, Chakwal, and the green ones, they indicate the colder Islamabad. So we notice here early bud burst and phenological development for the hotter site in all 4 cases, all 4 cultivars, and relatively later ripening and development in the colder sites and colder vintage too. So one of the point here is that we cannot apply same set of management for the locations or for the cultivars, because cultivars also have differences up to 18 days, 3 weeks. So this makes the point that we need to be cultivar specific and location specific in terms of our management. While I was recording the phenology, there were some fascinating differences between the cultivars. I'll give the example. This was photographed on March 21. I'll take the example of Perlet. On one of the sites at Islamabad, it just like start of the bud burst, but at Chakwal, the buds are fully burst. They have full leaves as well, emerging as well. It's really fascinating. Like here we see it's fully bud stage, and here the buds are close to burst. Another example is for blooming, photographed on April 21, NARC Black, an indigenous cultivar in northern Punjab and in sub-Himalayan regions. At Islamabad, it's not at 50% bloom, but at the same date at another location, it has berry set. And if we look for the ripening time, I'll take the example of colored cultivar for more visibility. So on June 26, at Chakwal, the berries are almost ripened to be harvested, but at Islamabad, it seems it will take 2 more weeks to be ripened. Although the locations are same cultivars around 100 miles, so it also indicates the importance of regional management of the cultivars, not just general recommendations. So there are the phenophase durations. I have taken the example of one cultivar. I'll highlight only one duration, that is bud burst to start bloom. There's a variability up to 15 days. Like if the vintage is colder, the duration will be longer, up to 45 days. But if the conditions are hotter, like in Chakwal to 2019, there is a variability of 2 weeks, more than 2 weeks. But in case of growing GDD, there is a very limited variability. What it indicates that we can use this growing GDDs as a predictor of phenology, and other studies also support our findings that growing GDDs remain consistent regardless of the effect of the locations, because they are driven by the temperature, effective temperature. So based on our findings, we were able to develop a phenology model, and here is the phenology model framework. That's based on only temperature, no other variables, a simple version of the model that can be applied easily. And here are the weather files. We import weather files in the model, and then phenological observations in terms of quantitative numbers on EL scale, which I mentioned earlier. Then based on rate coefficient calculations, model development, and an independent data set for the evaluation, we can predict the phenological timings for the bud burst, blooming, color change, raisin, or harvest. So here are the results of our model prediction using growing GDDs, our effective heat unit approach. We see on the panel right side of the figure, all the black dots that are observed data points, and here is the bud burst as I showed in the scale. These are the quantitative numbers representing phenology, and here is the harvest. In all the cases, the observed stages, they fall close to predicted red line. And we have a pretty good, strong interactions and correlations and with a variability of 2 days. This indicates that growing GDDs can effectively predict the phenology of grapevine. I gave the example of one cultivar, and I'll give the similar examples in the next slide. Here is the independent data set. When we predicted the phenological stages for independent data set, we observed a pretty strong relations between the simulated and observed values, and our model efficiency was more than 90% with high agreement index of 0.98. That gives us enough confidence that the phenology can be efficiently predicted using heat unit approach. And then it's really important to know day of year, like which day of year our blooming will occur, when our harvest will occur. This information is really important in terms of management, because we cannot take 1 year's management to another season, one location management to another that might be a bit hilly area with the lesser temperature. So it's really important to predict. So our predictive model showed a pretty good response in terms of predicting the day when the stages will occur. The yellow, the green marks on the scale, they indicate the stages. Here is the bud burst, and last one is the harvest. So if you are interested more in reading our modeling approach, we have an article that describes how we can apply this modeling approach to other cultivars using limited data sets. And then it's really important to know about the physiology, because there are physiological mechanism that's going on behind the phenological development, and like chlorophyll accumulation, gas exchange, and photosynthesis in the leaves. It's really critical to understand how they vary with the stages. So for this, we follow the same experimental setup, and we conducted experiments on 4 cultivars, 2 locations, 5 growth stages, and 2 consecutive vintages. One thing I want to make clear here, that it's really important to select the right vine, leaves, exposed leaf to the sunlight, and follow the same for all your replications and timing of the measurement, because the exposure to the sunlight, if a leaf is shaded, its angle is different, which side you are sampling, it's really important. I'm not going to go more in detail of that today. Let's discuss about the chlorophyll contents. Here are the 4 figures in one panel, and on the top we see the 2019, that is a relatively hotter, and on the bottom we see 2020, that is relatively colder side. And then on the left there is Islamabad, that is relatively colder, and on the right there is Chakwal, that is relatively hotter. As I mentioned earlier, up to 1.5 degrees Celsius temperature differences. And then there are 4 cultivars. We see here that there are differences among the cultivars in terms of chlorophyll contents at different growth stages. And then if we look for the mean values, the relatively colder vintage has relatively higher chlorophyll. In terms of location, the relatively hotter location, Checkwal, it has higher chlorophyll. One of the things here is that we see here the dashed red lines is an indigenous cultivar, NARC black, that showed significantly higher chlorophyll contents compared to the cultivars. And during the hotter vintage, we see here it's not showing that high response. So one of the thing here is that it's not necessary that a cultivar that's tolerant to heat is. It's really important to understand, and physiological information can help us how sometimes it's misunderstood that without any evaluations, physiological evaluation, that a cultivar is both heat tolerant and drought tolerant. But the physiological information or measurements, they show how the cultivar could be different in terms of their heat response or their drought response. And then is the variation is the photosynthetic responses of table grape cultivars. The 4 cultivars, we see there are variations in terms of effect of locations, in terms of effect of seasons, in terms of growth stages. One of the things that is obvious is that there is an increasing response up till berry set in all 4 cases. That is a traditional bell-shaped response for the photosynthesis. As the season proceeds, it's dipped down. But one of the things that's different between the 2 seasons is effect of heat wave. In 2019, we had a very significant heat effect affecting the vines. Temperature was about 40 degrees Celsius for more than a week. And then because of the effect of the heat wave, the photosynthetic activities, they decrease in all 4 cultivars. And then there is some recovery because there is a mechanism and adaptation in the vine that they have recovery mechanism. If they are not damaged permanently, they can recover to some extent. And we'll also discuss how these physiological differences relate to the yield. One of the important point here is that these physiological responses also link to the canopy, how canopy behaves. And if some of the leaves are high photosynthesizing, some others are not high photosynthesizing. So understanding the whole canopy is important. And then is the transpiration rate. It follows almost the same response as the photosynthesis. And there is a dip due to the effect of heat wave, where we can see here that there was one of the cultivar or 2 of the cultivar, the dip was not as much as the 2 other cultivars, perlite and sugar. That shows how the cultivar, they can have some adaptability to the heat. And then water use efficiency, it also follows the same trend, a bell-shaped. If we ignore the heat effect here, that it peaks for blooming to berry set period in our 4 cultivars, and more water use efficiency is reported at the colder location for the colder vintage. Here is a multivariate analysis of our physiological understanding. We see in the water use efficiency, photosynthesis, transpiration rate, and stomatal conductance, they closely relate to the colder location Islamabad and the colder vintage 2020. And that closely relates to the yield in 2020. We had a very exceptionally high fruit yield in 2020 that relates to these physiological responses. So it's really important. One of the other thing I was curious, can we predict the physiology, or can we predict the photosynthesis? It was a very tough question because there is a lot of variability in the canopy as the season proceeds. It becomes really hard to evaluate or understand how the vines will behave. So then I escaped and I understood that there is a period where we can have some relations, and that is a berry set period. From 5 leaf to the berry set, we have a quadratic relation of the growing degree days. with the photosynthesis. What it means? It means that we can predict berry set and growing GDDs can show relation with the photosynthesis rate till berry set. And then I evaluated the relations of the photosynthesis at different growth stages. Here is only for berry set for one cultivar, King's Ruby. Unfortunately, we don't have a lot of data points for this cultivar to link with the physiology, but based on 2 locations, 2 seasons, the photosynthesis rate at berry set strongly correlates with the yield. So it makes sense that berry set is a very crucial stage in terms of management in vineyards. So next is the seasonal variability in terms of berry ripening in table grapes, because the growers or industry is concerned about the fruit, the product at the harvest. So we follow the same experimental setup for cultivars. I'll give only commercial traits here that are sugars, acids, and maturity index. And I'll share the link for details if you're interested in anthocyanins or ascorbic acid, how they behave. So one of the trend is here. The red lines, they indicate the hotter location. The blue ones, they indicate the colder. And the solid lines, they indicate the 2019, that's a hotter vintage. And the dashed line, they indicate 2020, that's the relatively colder vintage. So we see there is a high level of total soluble solids for the hotter conditions compared to the blue ones that are the colder conditions with variability in terms of cultivars. In terms of titratable acidity, there is also a response. There is a decreasing trend, and colder conditions indicated by blue lines, they show relatively higher titratable acidity. That means that hotter conditions, they negatively interact with the titratable acidity in berries. And then is the maturity index. That is a robust criteria. 20 is the minimum maturity index that should be met for the table grapes. If the maturity index is less than 20, there is less acceptability of the cultivar. It varies with the cultivar. Some cultivars, they have high total soluble solids and less acidity, so their maturity index reaches up to 50 that are really sweet. Like sugar one, as it with its name, sugar, it has high sugar and maturity index reaches. And in our case, in relatively hotter condition, there was high maturity index. One of the things important here is that it's important to understand that all of this effect is not only due to the temperature. There might be some effect coming from the solute balance in the berries. Okay, the seasons were closely related, and growing GDD is driven by temperature. This gives us enough information to plot GDD against maturity index and use growing GDDs for predicting fruit quality. I'm giving few examples, and I'll focus on maturity index. So after 750 growing GDDs, starting from berry set till harvest, there is a good correlation with a high agreement index of 86%, which means that growing GDDs can predict the ripening pretty well in table grapes. This is the data for the model development period, and here is the model evaluation period. I gave the example of 3 main variables that determine the ripening: total soluble solids, titratable acidity, and maturity index. In all the cases, observed and predicted values show pretty high agreement index, more than like 9.2 in total soluble solids, titratable acidity 0.94, and observed maturity index for 0.82. So what it indicates that we can effectively use heat unit information to predict the berry ripening in table grapes. I had also developed the model for anthocyanins and berry pH and ascorbic acid, but that's a long discussion. I'll just focus. And if I summarize what's important here is that phenology, physiology, and food quality, integrated understanding of all of them, three is really important. Like if there is a stress coming up from bloom to berry set stage, that's the time of peak physiological activity in terms of food senses, transpiration, and water use efficiency. What it's gonna do that there'll be less photosynthesis, and that will affect the yield as well. But in case of the grapevines, our food quality, not only yield is important, we are more concerned about the quality. So higher temperature will decrease acids, titratable acidity, it will increase sugars, maturity index will increase, ascorbic acid, polyphenol, and anthocyanins, they will decrease. And if we look from a physiological standpoint, the food senses will decrease due to the elevated temperature. Chlorophyll doesn't show much effect, but transpiration, water use efficiency, and stomatal conductance, they also decrease. But substomatal conductance, it showed slight increase. I have not showed the data here. But other thing is the optimum window. It's really important to identify the optimum window. Usually, sometime it's considered as growing season temperature, the whole growing season temperature, starting from March till July. That could not be a good criteria because the optimum window is for T minimum and T maximum. If T minimum decreases below the threshold, food senses is decreased. And if T max is increased above the threshold, that is 35 degrees Celsius for most of the cases in grapevines, but that can slightly vary, and we can use adaptive measures to slightly switch to the upper side, maybe 2 degrees Celsius, by partial shading, by applying additional irrigation, or some other practices. So if I conclude all of this, is that grapevine phenology and fruit quality are genotypic traits strongly influenced by growing season temperature. From a physiological standpoint, berry set is the critical growth stage for grapevines, and any stress at this stage will result in substantial yield losses. And are developed two models, grapevine phenology and food quality models, effectively captured temperature variability on phenological development and food quality at harvest. And what's take home here is the model predictions in terms of phenological timings, coupled with physiological understanding, can promote climate resilient viticulture through selection of adaptable cultivars, improved in yard management under data limited environments. So one of the things here is that although our study showed very strong correlations of growing days with the food senses and other variables, further studies are needed to establish the physiological relation with the heat units, because there is a lot of variability coming in terms of how we manage the vines, how we manage the vineyards, how many leaves we keep, how denser is the canopy. That are another area to be further explored, to be effectively used as a predictor of the physiology. Another limitation with the physiological model could be that later in the season, a lot of diseases, they come in the vineyard, they affect the normal physiological process, which the model currently are hard to predict. And further refinement in the equations can help how the physiology in the later season develops. The other take home here is that predictions of the berry set physiology, if we can predict the berry physiology in terms of food senses rate at the berry set and berry set timings, we can have some corrective measures in terms of adapting the vines to the stress conditions. With this, I acknowledge all the people who have supported, funded, collaborators who have been with me in this journey. I really appreciate their contribution, their support, and what's not if I don't acknowledge my mentors and advisors, Professor Taqi Ahmed, Professor Hugan Boom, Dr. Mukhtar Ahmed, Dr. Azam Khan. All of them, they helped me in my this research. So with this, I open this webinar for question and answers. You can put in the chat box, or you can send me email related to viticulture, I feel flexible in terms of any issues with the table grapes. Thank you.
Thank you for attending the webinar. To learn more about the Cyrus 4 portable photosynthesis system, visit ppsystems.com.